So, welcome once again to Service Mesh Academy. I'm Flynn. I'm a tech evangelist for Linkerd working at Buoyant. With me is Zahari Dichev, whose name I probably just completely butchered, who is one of the Linkerd maintainers. And most relevantly for this SMA, he is the one who's been working on lots and lots of Windows-y stuff for Linkerd. If you are interested in joining in and you have questions, the easiest way to do that is to join the workshops channel in the Linkerd community Slack at slack.linkerd.io. I'll be keeping an eye on that. I will also be trying to keep an eye on whatever things pop up on other chat platforms, but that's kind of iffy. So I think we are going to go ahead and get started. Actually, I think we'll give folks another minute or two to show up, and then we'll go from there. So in the meantime, how are you doing, Zahar? You wanna introduce yourself more than just the guy who does Windows?
Yeah, absolutely. So I'm doing fine. As you've already heard, my name is Zahari. I've been at Buoyant for like nearly 7 years. I have worked on both the proxy and the control plane. And I'm currently focused on our Windows support, of all things. I live in Bulgaria, so it's like dinner time here.
So we appreciate you joining in the middle of the evening.
What better place to be than here?
Of course.
Yeah, I'll talk about some of the fun aspects and not so fun aspects about getting Linkerd to work on Windows. So yeah, really excited to share some of that stuff.
Cool. All right, let's get to it then. We have a little bit of slides. We have a weird thing going on here. All right, excellent. That's how you know we're doing it live or something like that. We're going to talk a little bit. We're going to talk a little bit about some of this stuff. Then we're going to go to the demo. We're first going to talk about the fact that, yeah, you actually can run Kubernetes with Windows boxes, which is a little weird from my perspective, but it works great. Or so I am told. I don't actually have any Windows boxes, so we will be talking about Linkerd on Windows after that, because you kind of have to have Kubernetes on Windows first. We're going to let Zahari tell us what it actually took to get here, the fun bits and the not so fun bits, as he just said. We'll talk, I think, really briefly about what's next. I don't even think we have a slide for what's next. I think we're just going to make Zahari riff on that while he's
we don't need a slide
while he's doing the demo or something like that. Zahari does have a demo, which I'm looking forward to because I've never seen this work before. That'll be cool. And as always, we talk about gotchas because this is Service Mesh Academy. And we only really have one big gotcha so far, which is kind of cool. I have a bit of a confession. That URL, the QR code, that's not actually up yet, but it will be later today, I promise. You will need to be using Linkerd Enterprise 2.19.0. You cannot do Windows support with plain old Edge releases. So you must use Enterprise 2.19.0, which means that you must go and get a free Buoyant ID from https://enterprise.buoyant.io. I promise you, we will not spam you. I think we send one message asking if we can help you out or something like that. But we don't sell them to spammers in Bulgaria. Zahari won't even see your email address. It'll be cool, right? It's fine. And it'll only take a few seconds to get it set up. If I understand correctly, Zahari, you're going to be using Azure for this?
Yeah, that's correct. Actually, as of like 3 days ago, I think, all that stuff should work just fine on EKS as well. So like if you want to try that out with AWS, you're free to do that as well. So yeah.
Cool. But in theory, if you have some other kind of cluster with Windows nodes, it should work.
Should be fine. Yeah, absolutely.
Yeah. And I realize this is kind of obvious, but if you are planning to run stuff on Windows nodes, then you will need Windows containers to run on your Windows nodes. You can't
Certainly.
pick up a Linux container and expect it to work, which made me sad when I found it out, but did not surprise me. We normally have a long list of tools for things if you want to follow along, and this one you pretty much just need kube control 2.19. So, and again, we're not showing the Linkerd installation because Zahari already has it set up. When we post the source, there will be detailed instructions. My understanding is pretty much that you just install Linkerd. I am given to understand it is not complex.
Yep, that's true.
Oh, good. So let's talk really briefly about Kubernetes on Windows, which kind of is Kubernetes, right? The backstory here is that Kubernetes clusters, which probably everybody knows, are built out of nodes, which are basically, machines. So you can have a cluster running a single node. Don't do this in production. If anything goes wrong with your node, your entire cluster goes down. That's very bad. So most real-world clusters will have multiple nodes. And usually these machines have been running Linux historically. You want to get really specific about it, they can be virtualized or they can be physical. But generally speaking, they're running Linux under the hood on the node. It turns out that you can just run Windows as well. Is there any particular kind of Windows you have to run for this?
I'm not really sure. I think anything from 2019 onwards would do the trick. At least that's what's offered on
Would you have to
cloud providers.
Do you have to get the Windows Server license or things like that, or
Probably, yeah. I think so. I'm not particularly familiar with all the legalities around it and the licensing situation, but yeah.
What we see a lot. Go ahead.
I think you need to run the server edition of it in order for all that to get working.
What we have been asked about in a lot of cases is people who want to use Windows nodes with cloud providers, in which case this is the cloud provider's problem. If you want to build your own, probably going to need the server license, yeah. Although, if any of y'all happen to know that I am wrong about that, let me know. That would be good to know. As Zahari mentioned, anything from 2019, back in Kubernetes 1.14, that's when they announced, hey, we have production quality Windows node support. That was in 2019. It was a long time ago. It was 20 releases of Kubernetes ago. So that's kind of cool. There is one gotcha here, which is that you cannot have a Windows-only cluster at this point. The Kubernetes control plane, like etcd and all the stuff that runs Kubernetes itself, still only runs on Linux. I am honestly not sure if that's because there's some reason it can't run on Windows, or if that's just because nobody has really needed it yet.
Well, it could probably be the case that there's a lot of components that have been battle tested on Linux that go into the control plane, and essentially maintaining them and making sure that they work as well on Windows as they do on Linux is a major effort that essentially could be avoided by introducing the constraint that you need to have the control plane running on Linux. So that makes sense in my mind.
Yeah, that would get down to a bandwidth and need thing, really. Testing, if for anybody who is not familiar with what goes into the Kubernetes core, testing Kubernetes is really hard. It's a royal pain. I am also told by Dieter, who is doing Windows-y stuff on Kubernetes, that you can actually use the Windows 11 Internet of Things license instead of the Windows Server license, which is good to know. This is why we like knowing people who know things. Okay. This brings us into Linkerd on Windows, which is pretty much Linkerd. Linkerd is a service mesh. A service mesh is an infrastructure layer providing security, reliability, and observability at the platform level uniformly across the entire application without having to change the application. Everybody has heard this definition before. none of that definition says anything about what operating system you're running it on. It makes as much sense if you have Windows nodes as it makes on Linux nodes for exactly the same reasons. You can have Windows applications talking to other applications. You would like that to be secure. You would like that to be observable. You'd like to be able to do reliability stuff. All of this makes a lot of sense. There are a lot of details, as always. And the biggest detail in terms of low-level crap that Zahari gets to talk about how much fun it was is that fundamentally what Linkerd does to do what it does is takes over the network. This happens very far down at the kernel's routing layer on Linux and presumably at the kernel's routing layer on Windows, although I don't think they call it the kernel really at that bit.
They actually do call it the kernel, but yeah.
Cool. I should probably back up a little bit, right? I am fairly well known for preferring Unix to Windows boxes. That actually doesn't mean that I know nothing about Windows, but it does mean that I like to play up knowing nothing about Windows. So, all right, I should probably stop that. The way that you take over things on the Windows side of the world is completely different from the way you take over the network on the Linux side of the world, because the networking stacks are really very different. So we will let Zahari talk about some of the fun bits of that. One of the things that actually makes this work better is that Linkerd doesn't really rely on trusting the network. There's not a lot of stuff where it sounds silly, right? But we are coming at this from the perspective that the network is a thing that somebody else controls, that we don't get to control IP address allocation. We don't get to control stuff down at layer 2, right? So from our perspective, the network is a thing that we are agnostic to and that we do not trust. And that means that as long as we can get some of the basics, then we're okay, which is a thing I actually really like about Linkerd. One important gotcha here, which is kind of not really a gotcha given Kubernetes, but the Linkerd control plane also has to run on Linux. So as long as Kubernetes requires you to have at least one Linux node, this is not a big deal for us. If that restriction ever goes away, then we'll have to do something about it. I expect that that's also a similar, mostly testing thing, right? Because
yeah, essentially it's a similar situation. I mean, like, we are quite familiar with the runtime characteristics of our control plane on Linux nodes. So we want to essentially like stay in this ecosystem in order to be able to support Linkerd effectively. And it's also just kind of like an effort optimization around like effort. It does take work in order to adapt a lot of the components to work on Windows, because there are certain underlying OS concepts that we need to make sure that they hold true in our code for Windows as well. So we've made the decision to essentially just keep the control plane on Linux. Well, it was hard enough like getting the proxy to run on Windows. So,
yeah. For those who have not looked into it, which is honestly probably everybody who doesn't work at Buoyant, the control plane in Linkerd kind of sounds like it should be relatively straightforward, where all it really has to do is keep track of services and configure the load balancers, and the load balancer being the part of Linkerd that routes traffic to different workloads. There are some alarmingly complex things buried in there if you actually look under the hood, and trusting all of the underlying things to work the same and to behave the same in the corner cases on Windows as they do in Linux is a fascinating proposition that would need a lot of verification. So, yeah. So, yeah, you can have applications running wherever you want to. Linkerd itself needs to be running on your Linux node. You don't, I believe, have to do anything in particular to make this happen. Kubernetes will do the right thing because you're handing it a Linux container and it will schedule it on Linux nodes.
Yeah, that's mostly correct. I mean, you would need to set up OS selectors, so your like workloads come on like essentially are scheduled on the correct nodes. But Linkerd control plane already comes with these selectors baked in. So out of the box, it should land on a Linux node given a hybrid environment.
This is why people other than me show up, so that when I say things that are wrong, they can call me out on it in public for posterity. Cool. All right. Zahari, you wanna walk us through the nightmare of the glorious and pleasant task of getting us here?
Yeah, absolutely. So there were quite a few things that needed to change around just the proxy and how it like handles the networking stack. So one thing in particular is that like we are using this original DST setting of the socket in order to obtain essentially the destination to which the connection was going before it was rerouted by the underlying routing infrastructure on the operating system. And in this case, in Linux case, that's IP tables, right? So we use IP tables in order to steer traffic to the proxy, right, in a pod.
I should probably point out that, for the record, when we talk about IP tables, we might be talking about IP tables or NF tables, depending on, right?
That's correct.
The general Linux packet filter is the thing we're really talking about. And
yes.
This original destination thing is important because we use the packet filter to snare TCP connections that are originally going to an application container and reroute them to the proxy container.
But the proxy, being essentially a proxy, needs to know where that stuff was originally destined to, right? And that's where the socket options come. And original DST is one of them. And that's kind of like written by the underlying network routing infra that we are stepping on. And we were doing that manually, essentially, in the proxy, just obtaining the original DST from the socket on the inbound. And, that wasn't essentially working for Windows, right? So we had to change that bit in order to enable being able to read that information on a Windows machine. Because, again, there is no NFT tables or IP tables on Windows, right? And more on that later. So that's one of the changes that needed to happen on the proxy side. Right? And then there were all the other bits, such as handling shutdown signals. So like the life cycle of the proxy being a sidecar is quite important to just kind of like the life cycle of your pod, right? And if you look at the proxy source codes, it uses it used to use essentially Unix signals for terminating the proxy and listening for shutdown. Now these are different essentially on Windows. So we had to change that bit as well in order to enable that. Now
it's kind of fascinating that Kubernetes. Yeah, that the Kubernetes runtime, actually I should back up a moment. It has always fascinated me that the Kubernetes runtime doesn't have more to say about the lifecycle and signals and things like that. And you can have wildly different behaviors on different Kubernetes clusters.
Indeed, yeah. In fact, that's even like globally configured, if I remember correctly. Like you can specify custom signals for like shutdown and all.
I think that's true. Yeah,
I think it's true. Yeah. So it's a kind of like it's the Wild West when you get into these things there, especially when you like compare Windows and Linux. So that was like one of the other bits that needed to change around the proxy, right? And then obviously
I'm just curious, was that something where like the proxy would keep running long after it was supposed to, or was it something where you would be going along and the proxy would just suddenly die?
Kind of undetermined. Like I've seen situations where like the pod would get like forcefully killed by the Kubernetes runtime because it was like the container was not shutting down. So it's like there's various behaviors that you can observe. It's kind of like for Windows, it is even the case that once you move from a Kubernetes version to the other, behavior might change. So it's very unpredictable. And to tell you the truth, one of the most reliable ways to implement shutdown for Windows containers is to essentially have like I think it was called like a pre-stop hook, right? That essentially pings a shutdown endpoint on a server that's listening in your application. So don't rely on, this is not what we are doing, right? Or maybe we're doing part of it. This is like I'm kind of like some of the details are sort of running away from me, but that's essentially one of the most sure ways to implement shutdown behavior that's platform agnostic, right? Because it relies on something that's not tied to OS specifics. But let's not deviate from the main topic. Then another thing that had to change is now it's running Windows containers, and just like Windows support in Kubernetes comes with certain restrictions. And one of these restrictions is that you can't really have any sort of privileged containers, right? So on Linux, what we do is, in order to configure it, and most of you might probably know that, but in order to configure the network in an injected pod, we essentially run an init container that executes all the IP tables in the namespace of this pod, right? And that's what, but in order to do that, you need certain privileges on this init container, namely the capnet admin.
Capnet admin, yeah.
That's correct. Now, this is very convenient. Unfortunately, you can't really have that on Windows, right? You can't really have privileged containers. So
you can't have it on some other Linux Kubernetes either, right? Like if I remember correctly, correct. OpenShift just doesn't allow it. Full stop.
That is correct, and that's why we've had a CNI plugin for a long time now that works on Linux. And essentially, a CNI plugin is something. It's a container network interface plugin that plugs into the lifecycle of pod creation in Kubernetes. And it's something that gets executed on the specific node, like whenever a pod is created. And we essentially hook into this lifecycle in order to configure the network. Now, that's essentially what you need to do on Windows as well, since you don't have privileged containers. So what we had to do is to write our own CNI plugin that is specific for Windows, that hooks into this ecosystem and essentially configures the network for newly created pods. And
the funny expression on my face is wondering, how is that? Yeah, like there are a bunch of CNI plugins out there in the world for Linux that are literally a bunch of bash scripts. So what's the Windows CNI plugin?
Well,
is it a bunch of PowerShell or something?
No. So we decided to kind of stay a bit above ground on that one, and we've actually written our CNI plugin in Golang, right? So the CNI plugin that we've written consists of two bits. One of them is the CNI installer, which is a daemon set that runs on the node, one per node, and it places a binary in a piece of config, and I'll show you all of that in the demo on the said node. And in the other bit of the plugin is the binary itself that essentially gets called by kubelet each time a pod is created. Both of these components for Windows, for our Windows CNI plugin, have been written in Golang. And that actually worked quite well.
Cool.
Now, there are certain complications around having such a CNI plugin. So, for example, some of the cloud providers don't really like that, and I'm not gonna like finger point specific names, but I have observed situations where a node is restarted with our CNI plugin installed, or a node is upgraded, and then the configuration that we have provisioned for CNI essentially gets wiped, right? So, so our CNI plugin needs to listen for that and be kind of really, really defensive against such behaviors, right? So we had to take care of that as well.
We have to do that on the Linux CNI plugin as well.
We have to do that
we?
on the Linux
Yeah.
CNI plugin. Our Linux CNI plugin is written in Bash. So, monitoring and doing file watches in Bash is a whole different ball game as opposed to Golang.
So what I'm hearing here is I should expect a rewrite of that CNI plugin in the not too distant future. This is the point where I have to remind anybody listening that I do not work in engineering and I do not get to set engineering policies. So anything I say about what engineering is going to do, you should ignore or take it as a wish or something. But yeah, one of the biggest problems with CNI, with the CNI in general, is that its API is basically run an executable, and there's a fair amount of work going on in with some of the Kubernetes SIG network folks and things like that, trying to figure out, can we do something better here? And it's kind of fascinating.
It's probably good to try and do something better, on this front, because it's a fairly cumbersome API. Like having a binary being run on pod creation robs you of a lot of the things that you kind of get, you've kind of take for granted in Kubernetes workloads, like metrics and error reporting, being able to tail logs and on just like a single pod. So all of this could be implemented, but it's a lot of work to do that correctly.
It's the first chunk of the work is actually around figuring out what semantics would need to be exposed by such an API, and there were some pretty entertaining conversations about that in Atlanta not too long ago, actually. But yeah, it's not a great interface, certainly.
No, it's not. One other interesting bit about the CNI on Windows is that now, if you don't have IP tables or NFT tables on Windows, like
you must have something.
You must have something. What does it do, right? Well, on Windows, what it does, our CNI plugin, is that it essentially looks. So when a pod, so it's like the Windows networking model is a bit different. So when a pod starts, there is some logic to set up what is essentially like a network endpoint that is essentially the IP address of the pod, right? It's like a compartmentalized representation of the pod, and that lives in like a namespace, or what's the equivalent of a namespace on Linux. And this is all governed by a service called HCN, which is the host compute network service, if I remember correctly. Now there is a Golang API that is exposed, that you can use in order to make calls to this otherwise closed source service, right? And essentially what our CNI plugin is doing is that it intercepts the endpoint creation for each pod that is spawned, checks whether that's a pod that has Linkerd proxy injected, and if it is, and if it determines that the network needs to be configured, it just configures the network using endpoint policies that are applied to this endpoint in order for traffic to get routed, much the same way as it's happening on Linux with IP and NFT tables.
So that
that's
implies
the
also
role.
that implies also that endpoint creation thing has to happen after we inject Linkerd. Is there a race condition there, or is that just a thing that happens to be part of the way Kubernetes works?
I would say that's part of like Kubernetes works. So by the time the CNI
That's
plugin
nice.
is called, you should essentially have an endpoint created. We haven't really observed any race conditions around that so far. So that's how it works on Windows. You don't have these like IP tables and NFT tables, but you've got something else. And under the hood, this service, this HCN service, is essentially using the WFP platform, which is the Windows filtering platform. This is essentially the low-level API for programming firewall behavior on Windows. And most of the firewalls on Windows, essentially like Windows Defender and whatnot, they all, if I'm not mistaken, rely on this interface. Now, working with that is a lot different than what you get on Linux, but thankfully we've got like a Golang API that's a bit more high level. So these are sort of the things that kind of needed to happen on the dev work. And maybe we can move to the next slide here. Now, it's interesting that we write this code. That's great, right? Like now we need to test it. We need to integrate it into our CI pipeline. Now that's a task of its own, right? So how do you test such a thing? You've got the CNI plugin. You want to install it, and
I think we actually have another slide that talks a little bit about testing, but
I mean, with like just testing and building is essentially
kind of the same.
Yeah, they're sort of bundled into the same action file oftentimes. But essentially, you need a Windows runner, right? You need a Windows runner in order to build your Windows images. I mean, even if your proxy compiles on Windows, you essentially need to run on a Windows runner in order to output an image artifact that's for the Windows platform.
This is kind of a silly question, but is this a case where, if you're on a Unix box, you can fairly easily cross-compile to a different variant of Unix using Go. But if you try to use Go on a Unix box to produce a macOS binary, for example, you're going to have a lot of trouble. Is Windows more like macOS in this respect, where the cross-compiling thing just doesn't work?
And cross-compiling works, but like putting the image and building the image, it just doesn't really work that easily. And part of the problem there is that once you can get like a GitHub Actions runner that is Windows, but a lot of the tools that we take for granted, such as Docker build push action, all the tools for generating SBOMs and packing like OCI artifacts and all that stuff. This just like is not readily available on these runners, and you need to install it. And oftentimes there are quite a bit of hacks that you need to do in order to get these things running. So that was just getting the image produced was essentially like a task of its own, right?
I didn't even think about SBOMs. I'm not going to lie.
Yeah, it's like you would think that running the Docker build push action on Windows on the Windows runner is just a trivial thing to do, and you know what? Like it is. You can just like run this action on a Windows runner, and it's all gonna work fine until the point when you decide to set the SBOM flag to true. And the reason that it's not going to work is that in order to generate SBOMs, it uses the Sift BuildX plugin or whatever. That's an image of its own, and that has not been published for Windows, for the Windows platform. There's only like a Linux AMD 64 image there. So what you need to
Well,
do
oh,
is,
there's not even a Linux ARM 64? Come
I'm not
on,
sure.
people.
I'm not sure, but certainly there is no Windows one. So
Yeah.
what you need to do is you need to kind of generate your SBOMs after the fact and kind of bolt them on and all that. So it's like a lot of ceremony to get this Windows specific artifact out into the world.
Mhm.
This is all to say that, just writing the CNI plugin, getting the proxy to run, getting the injector all figured out, it's not like, that's not where it stops, right? So once you do all of that, you need to essentially handle the building part of it. And after you've done that, you need to start thinking about testing, right? So that's our next slide.
It's really interesting talking through some of this stuff though, because of the number of people that I've talked to who this often shows up when we talk about changes that we made to the release model for Linkerd and things like that. And it's really fascinating to talk to folks who have not needed to think through how exactly you do all this stuff and how much effort it is, right? It's a
It's
lot
a
of work.
lot. Yeah, it's a lot of work to
Yeah.
get an artifact out.
Yeah, there's a really, really big difference between I am a developer and I've gotten this thing to run on my machine for testing, and here's a thing that you can go and install anywhere and it will just work.
Oh yeah, absolutely. And not only that, but it's like, where is this thing coming from? When you're
Yeah.
producing an artifact that's essentially like tier one critical piece of software, you need to have some certain guarantees around it. Like the image
Yeah.
needs to be signed, an SBOM needs to be included, like all of that stuff. And
Even
if
on a
you,
really simple level, you have to be able to know which commit from the source it came from, and it has to be possible to recreate the image given just the sources.
that is correct.
Both of which can be way harder than people often realize.
So it's a lot of
That's
work.
not just a Linkerd thing. That's for software development in general. Getting to a
Yeah,
place where you have known good reproducible builds is a whole thing entirely on its own.
that's correct. Yes. So like, once you're done with all of that fun, testing this comes along,
Testing is
right?
its
And
own brand of fun.
it is. And testing Linkerd has not been, just like getting an environment in order to test Linkerd in CI is not really hard. Right? You just need a
Tedious, I
Kubernetes
imagine.
cluster. But you just really need a Kubernetes cluster. So what we've been doing so far in our GitHub actions, in our integration tests that are part of our release process and like just PR building, emerging, is
And
to,
incidentally, that's part of the Edge release process as well as the Bell release
right,
process.
yes.
Testing is not something that's we don't skip testing in Edge releases, right? This
Yeah,
is
no, we
why
don't
we
know.
can say that the Edge releases are production worthy.
But what we do is just that we run a Linux runner in GitHub Actions and we create a K3D cluster, right? And that's great. But like now we are in hybrid land. So in order to test all of this, test the CNI, test the proxy injector, test the proxy on Windows, what you need to do is you need a cluster with both Linux and Windows nodes. And you just can't do that on a Linux runner. There are certain kind of experiments that I've tried. So for example, like I've tried getting WSL, and for the uninitiated, this is essentially like a virtualization system
Windows
in
Subsystem for Linux, I think it
yeah,
stands for.
yeah, essentially, yeah. So you can run Linux. You can run a Linux operating system on your Windows box. So what I've tried to do is to run like a Windows GitHub Actions runner where I would run WSL and run a Linux distro in it, and use that as a Linux node in order to create locally a hybrid cluster that has one node that is Windows and one node that is Linux. Now, this has proven to be quite involved. So what we've done instead is to essentially produce some GitHub actions that would spin up on-demand clusters in a cloud provider that are hybrid. So we've got like this whole infrastructure set up where we can just, in a GitHub action job run, spin up a cluster on a cloud provider, do our thing on it. So install Linkerd, check that traffic flows, check that policy works and all that, and then just tear it down. So that was quite a lot of fun to do. And it actually works surprisingly well for our use case. So that was part of the testing that had to happen for this feature, because we can't really like just release it without exercising it in any integration test. So that was I mean, that was one of the parts that was not so annoying, to be honest. I mean, it's like we are using Terraform and in order to spin up these clusters, so it's like everything is just defined and principled, so we can very easily test our hybrid scenarios on a hybrid cluster.
I might have to go and edit this slide though. So since we ended up using the cloud provider instead, so
yeah, we ended up using the cloud providers. I mean, it's really not. You just need to be mindful when you run these tests. Like, you need to be mindful to not run them when there's no need for it. So yeah, that's kind of it. Like, we're using the cloud providers. I mean, I think there are projects out there such as K2S that can help us run on a Windows runner, a hybrid cluster Windows runner, but we just haven't had the time to spend in order to try to implement that behavior.
we will have to look further into that. And again, this is how you know we're doing it live.
Mm-hmm.
All right. I think that's the first time I've actually had to edit a slide that was just totally wrong in an SMA. So you have my heartfelt apologies, everyone.
It's all right. It's all right. I mean, so
Zahari and I talked about this beforehand, but apparently we missed that slide. But yeah, I think at this point we will swap screen shares and let Zahari show all this stuff off. Once again, if you have questions, the workshops channel on the Linkerd community Slack is the easiest place to do it. And otherwise, off we go.
awesome. It's demo time. Finally. So actually, this demo, I must apologize in advance. Like, this demo is not as polished as Flynn's demos with emojis and faces and all that. Mine is a lot more simplistic. But I'll try
that so it's a little easier to read.
I'll try to make it interesting, right?
And we could compile faces on Windows. I mean,
we can.
That is a thing we could do.
So what do we have here? So we've got...
Actually, Zahari, I think you should make that font quite a bit bigger for this particular session.
Like this?
A little bit more if you can.
I think more than that would just be strange. Maybe that's... Yeah, let's do that. Okay, cool. Right. Okay, so we're here, right? Does that work?
I mean, I'd go a little bit bigger still, but I can at least... Yeah, there we go. Let's stick with that.
Yeah. Okay. Cool. Okay.
So you got 2 nodes.
So I've got 2 nodes. I've got
and one of them's Ubuntu and one of them's Windows. Excellent.
Windows Server 2022. So I'm running on Azure. That's AKS, as you can probably tell. What else do we have here? Well, we've got Linkerd installed, right? And nothing else, essentially. So what we need to do first is to install our Windows CNI plugin. So the first thing we're going to be doing here is we're going to install this CNI plugin.
Now that's a little bit different from
Sorry. Hello? Okay, so I think we've got some technical problems, but I'm just trying to share my screen. Again, I think we need to wait for Flynn in order to...
All right, I think I'm back.
Okay, awesome. Now you probably want to share my screen again.
There we go.
Great. Okay, we're back.
Well, I'm not entirely sure what happened, except for my house apparently got knocked off the air for a little while.
Ooh.
So, yeah, okay.
That just gave us enough time to get the Windows CNI installed. And this is essentially this pod,
Excellent.
this daemon set here. Yep.
Zahari, I was going to ask, if I remember correctly, when you install Linkerd and you want to use the CNI plugin on Linux, there's just a Helm switch where you say, hey, go ahead and install this. Is that the plan with Windows, or do we expect that this is always going to be a separate thing that you need to install?
Essentially, this is not decided at the moment.
Okay.
At this time, it's a separate Helm chart. And
Mhm.
there are benefits to having it as a separate chart. That gives us the opportunity to just decouple it from the release cycle of Linkerd, which is a good thing.
Which is good, yeah.
So I like that for the time being. I'm not sure what the future holds on that front. So now that we've got this CNI plugin here, we are actually ready to inject some pods, right? So we're going to create a namespace called WinDemo, right? And we are going to add a client. So we've got this client workload that is essentially just like a curl image, right? So we are going to apply this workload here, and it is getting injected, right? And now we can SSH into this we can inject into this workload. And we can inject into this workload and start hitting a server service that lives in WinDemo. So let's create that. So now you can see that there is not much happening, right? We're getting essentially empty responses because there's no pods that are backing this service. What we can do is create our Linux server here. And this Linux server is essentially a pod that runs an HTTP server and responds.
BB is an old testing thing that I think Buoyant wrote a long time ago, right?
That's correct. Yes. And that replies with just a simple hello from Linux message. Now, what we can do as well is to add a Windows server, which is a workload that has a few interesting things about it. Right? So first of all, its inject mode is set to Windows instead of enabled. Yeah, you don't necessarily need to do that. If you've got a node selector that selects Windows nodes only, and we do that here, the proxy injector will know that this is a Windows workload and will configure it to be a Windows workload. So this is a Windows workload and should run on the Windows nodes. It runs a Python 3.9 on Nano server, and I've given it a Python script that's gonna spin an HTTP server that replies with hello from Windows. So let's see whether that works. And you can see that it's getting initialized. We should start seeing some responses from our Windows server soon enough. I hope.
There we go.
So, sticky load balancers, we probably need to give it some time. No Windows responses.
This is what happens when you do the demo live, right? I mean.
Oh, here you go. We've got some responses from Windows. Hello from Windows. So that's our Windows workload. And in fact, this is.
We just had to complain about it a couple of times as well.
True. So what can we do in order to make sure that this is actually injected? Well, we can always tell the proxy logs of this workloads, but what's better is to try and see whether we can actually use some of Linkerd's features on Windows, right? So we've got two server definitions here, right? Server 1 and server 2, and one of them captures the Linux pods and the other captures the Windows pods. So once we apply this, we are going to stop seeing any responses because these servers will automatically deny all traffic because they don't have any authorization policy attached to them, right?
And because they don't have a, oh man, I don't remember the name.
The default policy?
The thing that we add, the thing that we added, access policy, I think it is, right? And servers default to an access policy of deny.
That's true, yeah. And now we have stopped seeing responses. So what can we do? We can just create an authorization policy that requires allows meshed connections only. But we can attach that authorization policy to server 2 only. And server 2 is the one that selects over the Windows pods. So if we do that, we should start seeing responses only from Windows. And if we look at the header responses, we can see, we can see 200s coming from Windows, and we can see 403 forbidden coming from the Linux pods. So that's kind of proves that we are actually meshed, right? We are meshed for real. Now, let's actually look at what's happening in these Windows nodes. So we conveniently have the CNI plugin here running as a daemon set on the Windows node. We can exec into it. And wow, that's even surreal to observe, right? It's a PowerShell prompt
on a Kubernetes container.
On a Kubernetes cluster, right? So what do we have here? Essentially, what has happened is that our CNI plugins configuration is residing here in CK Azure CNI netconf. And we have this conf list file that essentially specifies the default CNI plugin here for Windows that Azure ships with. And we have appended our Linkerd to Windows CNI with some settings. So what's our inbound proxy port? What's the outbound proxy port? What are the proxy ports to ignore? What's the proxy user ID? Yeah.
What in the world kind of user ID is that?
It is a security identifier that is baked into the Windows Server operating system. Yeah. So it's a pre-built security identifier, it's a pre-built user ID that we don't need to create. And that's just the config. The binary is here, Linkerd Windows CNI. And I mentioned earlier about endpoints, right? You could see that here we can call this convenient utility on the Windows box to get all the endpoints that have been created. And we can see, ooh, that's crazy. Right? Like we can see the endpoints that have been created, and we can see the policies that have been applied. And if we squint our eyes and look carefully enough, we'll see this policy called L4WFP proxy with an inbound proxy port of 4143 and an outbound proxy port of 4140. So this is the WFP Windows Filtering Platform proxy policy that gets applied through the networking service and configures the underlying filtering platform on Windows. And that has been applied to this endpoint that has a bunch of other policies applied as well. And that has been applied by our CNI plugin. Yeah. And you can see that endpoint has 3 shared containers. So in our situation, that would be the proxy container, the proxy init container that validates that the network is correct. So it's like each of these pods is running a network validation container that ensures that the network has been configured correctly. and the application container. Right? So we've got so that essentially sums up to
the network validator, if I recall, is literally making sure that we really did get to take over the network.
that
And
is correct.
it will just exit and kill the entire pod if something is wrong, right?
Yes, that's entirely correct. And if you want to even look at other things that are interesting, we can get the logs from the Microsoft Windows Host Network Service and look at. I admit I copy pasted that command and look at.
That's good.
Look at the events that are being generated, and we see this HNS policy application event that's getting generated here. We can even look at that JSON. You can see these policies being applied here, right? So we're applying an HNS policy on this particular endpoint, and this is an ACL policy, and there are a bunch of other policies such as L2 driver and whatnot. So this is like deep into the Windows, ecosystem. So that's kind of the demo, really.
Cool.
I can just stop sharing my screen.
We'll give folks another couple of minutes if they have questions. Actually, while we give people a minute or so, if they have questions, then I shall go ahead and get the slides back up. All right. Yeah, if people have questions, now is a great time. I am going to go ahead and reinforce this particular gotcha. You have to run the Linkerd control plane on Linux. As Zahari mentioned, if you just install it without messing around with the YAML or the Helm chart, then it will do the right thing by asking the scheduler to schedule it on a Linux node. If you're one of those people who really likes to mess with all the YAML by hand, maybe don't remove that particular constraint or bad things will happen. I assume that if you try to schedule it on Windows, it will just promptly go into crash loop back off and nothing will happen and you will not go to space today. So yeah. Are there any other gotchas that come immediately to mind, Zahari? Putting Zahari on the spot. All right, good. That's what we like to hear, or not hear, as the case may be. We do have a question from Slack about whether we plan to have the Windows proxy image available on Edge releases, and I do not know that we have an answer for that yet.
We don't have an answer for that. We do have the Windows proxy binary available on Edges. That's about it for the time being. So if you're adventurous enough, you can pack yourself a proxy image out of the binary.
It's a nice lead into things coming next, if there's anything that you can share there, actually.
So I think what we are looking, and that's in no way a commitment to any particular deadline or shape of effort, but we are essentially looking at what does it take to have Linkerd be compatible with meshing external workloads that run on Windows nodes. So that's one of the things that we are exploring, and things get quite interesting there. We're talking like
mesh expansion for Windows.
Mesh expansion for Windows, yeah.
That would also, that would presumably allow you to do things like have your Linux cluster be able to mesh an external Windows application. That would be
Yes,
interesting.
that is correct. Yes.
Yeah,
Yeah.
that would be cool. That's, I think, as far as I can take it there.
So I mean, what else is just improved support for the CNI plugin? Maybe integrating it more tightly with the Linux control plane. There were some ideas, and again, that's non-binding, around like making the CNI plugin, well, essentially merging the CNI plugins for Windows and Linux into one shippable binary.
Yeah.
I mean, they do share a lot of the logic around provisioning the plugin and provisioning the configuration for it and handling all the edge cases. Where they differ in the API around what needs to get configured. Where they differ is the underlying network configuration engine, and that's what this whole system needs to be generic over.
How would you really mean a single binary, or do you mean, you build the binaries from the same sources?
You build the binaries from the same sources. Obviously, like one of them needs to
Yeah.
be compiled for Windows, one of them needs to be compiled for Linux. So
I was trying to think about whether,
just single
whether there was,
source.
whether there was a way to even do that I didn't know about. So, okay.
I don't think so.
Yeah.
I don't think so.
It would be weird.
Yeah.
to do that. Okay. Sorry, I've kind of gotten derailed thinking about Windows Mesh expansion and going, well, I mean, at least you can run Spire on Windows. And
you can, we've tried that. You can run Spire in Windows. It uses named pipes as opposed to Unix domain sockets. It's perfectly fine. It's experimental.
They're kind of the same thing.
Yeah.
That's the cue for all the networking purists on Linux to go and beat on me. But no, really, they're kind of the same thing, guys. I mean, yeah. Okay. All right. I'm not seeing other questions. If we get more, then we'll come back to them. In the meantime, probably a lot of you have seen this slide already, but that QR code will take you to a survey about what you like or don't like about Service Mesh Academy. This is a big help for us to hear back from people telling us, especially what they don't like, so we can fix it. Buoyant Enterprise for Linkerd. The demo that you saw was using Buoyant Enterprise for Linkerd version 2.19, which came out really recently, actually. Last month? I don't quite remember. It's the latest and greatest. You should go check it out. It's good stuff. Buoyant.io/enterprise-linkerd, or scan that QR code. We also have a bunch of online courses at learn.buoyant. Well, okay, maybe not a bunch, but we have some online courses at learn.buoyant.io. Check those out as well. And next up, January 15th, my colleague Phil Henderson is going to be talking about a guide to Linkerd production readiness, as in, if you're sitting there staring at your system and going, oh yeah, we're going to be running this production environment, we got to set it up from ground zero, we're going to run Linkerd on it, what should we do? We have opinions, and we would love to share those opinions with you so that things will go a little bit more smoothly than we sometimes see them go. And on that note, if we have, we'll take another minute or so for questions before we call it. But in the meantime, somebody is typing in Slack, so we might have another question. But in the meantime, thanks, Zahari. Much appreciated. Always nice to have folks on the show who, know things that they can talk about. Our typer has, now he's typing again. Or maybe not. Well, at any rate, we'll go ahead and shut down the live stream, but the Slack always works to reach us. I am Flynn. on the Linkerd Slack. Zahari is also on the Linkerd Slack as Zahari, or maybe Zahari Dichev. I don't remember.
Zahari should do, yeah.
Yeah, I expect there's only one Zahari on most of the Slacks. So yeah, thanks much. Appreciate it. We'll do it again sometime. And in the meantime, we will see everybody in January. Happy holidays. Happy New Year. I can't believe that the next SMA will be in 2026. That's just crazy.